Hi everyone, welcome to the third video. In this video, we'll be covering the topics of file operations, modules, and libraries. So let's get started with the topic of file operations. So far in our programs, we have been getting input from the user and then printing out the output to the user. However, there are other ways to get input and to store output when programming. One of these ways is to get the input from a file and to store the output to a file. So in this video, we will be seeing how to do this in Python. Okay, so in our file explorer, we can create a new text file. For now, make sure the text file is in the same folder as the Python file that you're working in. So I'm working with this video3.py Python file, and I'll create the text file here. If you don't see the .py on the Python file, then that means that your extensions are hidden. So go to View and then make sure that this button is clicked. If it's not clicked, you'll see that the .py will not be displayed. So make sure that is enabled. And then we can create a new text file. And by default, a text file has a .txt extension. And you can name the file basically whatever you want. I'll call mine zen.txt. Can then go ahead and open this file in Notepad. Okay, so in Notepad, you can go ahead and type whatever you want into this file. What I will do is paste out this passage. This passage is known as the Zen of Python. It's basically what the philosophy of Python is about. So you can look it up and read it if you're interested in learning a bit about the philosophy of Python. But then I will go ahead and save this file. And what we can do next is use this file as input data for our program. So to do that, we first need to open the file. So we do that using the open function. And in the function, we put the name of the file. And we store the return of that function into a variable. So I've just called that variable file. So now that we've opened the file, we can start getting data from the file. So one way you can do that is to just read out the entire file. And that is done using the .read function or the read method. So what the read method does is it will take all the data in the file and return it as a string. So we need to store that data into a variable. Now I can print out that data because that data is in the form of a string. So what this does is get everything that's in a file into one string, and we're storing that string in a variable. So if I print it out, it should print out the entire file. And the last thing we have to do is actually to close the file. So in programming, a lot of times when you open something, you also have to close it. Now, if we didn't close this file, then other programs that might try to use a file might run into errors, or some other worse things could happen, such as the file might take up extra space in your memory, and every time you run the function it will take up more and more space. However, that probably will not happen in a small example like this, but you want to build a habit of always closing your file after you open it. So now let's run this file and see what happens. So I've switched to the shell output, and you can see that the entire file got printed out as we expected. Now there are many other things that you could do instead of just reading out the entire file. For example, if you put a number in the read function like 100, it will only get the first 100 characters of the file. So if I run this, you can see it stops in the middle of this word because it went through 100 characters. If I then make a second variable and I call the read function again with, actually let's say 50 characters this time, and I print out this new variable, what it will do is get the next 50 characters in the file. So let's run that and see what happens. Okay, so you can see the first file data, the first variable, printed out these 100 characters, and the second one printed out these 50 characters. So you can see the 100 characters took it up to this word complex, and it stopped in the middle of the word. And then the next 50 characters started at the L in the word complex and went down to this word here. So if we go back to the original program, which is just using the straight read method, remember that it returns the entire file as a string. So this variable is actually a string. So anything that you can do with a string, you can do with this variable. For example, you can convert it to uppercase. So if we print out the uppercase version of this variable, it will print out the entire file in uppercase. And you can see that here in the output shell. You can also do something else, like get a particular character at a specific index. So if we want the 100th character from the file, we can do it like this. Well, actually, this will give us the 101st character in the file because indexing starts at 0. So if we run it, we see we get the letter L, which you should have expected because remember, the first 100 characters took us to the P in complex. So the next character would be the L in complex. Another way you can read a file is to read it one line at a time. So this read line method, it will return the first line of the file as a string. So here we're storing that first line in a variable named file data. And if we run this method again, like here we're running it a second time, and this time storing the return in file data 2, what it will do is give us the next line of the file. So file data should be the first line of the file, and file data 2 should be the second line of the file. So let's run this program to see if that works. And here you can see it works. It prints out the first line and then the second line. And you can keep calling this method as many times as you want until the file runs out of lines. Now, if you want all the lines of a file, what you can do is use the read lines method. So what that will do is return a list of every line in the file. Each of those lines would be an individual string in that list. So we're storing that list in file data. And if we print it out, let's see what happens. So the output seems a little complicated, but let's take a closer look at it. So we can see it's actually a list because you can see the square brackets. And here is the first element of that list. Here is the second element of that list. And here is the third one. So you can see based on the quotation marks that it's actually a string. Each element of this list is actually a string. And you can see the first string is of course the first line of the file. The second string is of course the second line of the file, and so on down to the last line of the file, which is the last string in this list. Now, one thing to note, or rather two things to note, is because these strings are in a list and not printed out directly, you will see the quotation marks. So that's the first thing. The second thing to note is that each string ends in this \n. So what does this \n mean? If you have not seen it already, this \n is how you represent a line break in a string. So at the end of each line, there is of course a line break which says to go to the next line. So when we get the read lines, when we use the read lines method, it gets that line break character from the end of that line as well. So these are included in the string. So that's something to note. On that same note, if you print out a string which contains \n in it, it will actually go to the next line in the output, whatever output that you print out. So let me just show you that quickly. So you can see it printed out A, then it went to a new line, then it printed out B. So the \n represents a line break, meaning go to the next line. And you can include it in your own strings as well. So going back to this program, since we have a list of each line of the file, we can loop through that list and get each individual string in that list. So if we print out each line instead, you can see each line gets printed out. Now, You might notice that there is a blank line in between each of these, and that's because, remember, each line from the readLines method has the line break at the end of it, and when you print out something, it automatically puts a line break for you. So the first line break goes to the next line, and then the second line break from the print function creates a blank line. So that's why each line has a blank line in between it. And just to emphasize, this line variable is in the form of a string, so whatever you can do with a string, you can do with this variable as well. So if we want to print out the 6th character in each line, we can do it like this. So let's run that and see. So we can see in the first line, the 6th character is an I, then a C, then an E, then an E, and so on. And you can see the I is from the word beautiful, the C is from the word explicit, the E is from the word simple, then from the word complex again, and so on. Now, there are times where you might actually want a list of each line of the file. However, most of the time, you just want to loop through that list. And in Python, there is actually a shortcut to do that. So instead of getting the list of lines using the read lines and then storing that in a variable and then looping through that variable, you can actually just loop through the original file object from the open function. And this should give us the same thing as before. So here you can see it gives us the same thing as before. If I remove this part and print out the entire line, you can see once again it gave us the same thing as when we printed out the entire line. So this is just a shortcut that you can use whenever you just want to loop through each line of the file. So that is how you open a file to read the data in that file. And next we will see how we can store our own data from the program into the file. So in order to store data to a file, we first need to open a file just as you would when reading data from the file. However, we open it slightly differently. We add a second parameter to the open function, and it's a string containing the letter W. So W means write, and it means that we want to store data into the file. Now, just as a warning, whatever file you put, whatever file you specify, if you already have that file in this folder, then it will be deleted and a new file with that name will be created. So you just need to be careful that you don't delete any files that you have in your folder. So the file I'm going to use is out.txt, and here's how you use this file. So we still store the return of the open function in a variable. In this case, I still called it file, and we can now write to that file using the write method. And in that write method, we specify a string that we want to put into the file. So the string I've used is hello world. So if I run this, what it will do is create this file in the same folder. If that file is already there, it will delete it and create a new one. And then it will store this message into that file. And as usual, you still need to close the file. So let me just show you that my folder does not currently contain this file. So if you take a look at my folder, it currently does not have the file. So now if I run the program, you can see it ran. And if I switch over to my file explorer and refresh, actually it's right here. So I can then open this file in Notepad. And if I switch over to that, there we go. You can see it puts that message into the file. Okay, and just as a note, whatever you put into the right function must be a string. So if you want to store an integer or a float or some other type of variable, you must convert it to a string first. For example, by using the str function or by using string formatting. And when you read data from a file, it's in the form of a string, so you must convert those from a string to an integer or a float if that's what the form of the data you want it to be. Continuing with the write function, you can run the write function as many times as you want, and each time it will keep adding the data to the file. So if I put the word world first, or rather second, and only have the word hello in the first one, when I run it, okay, so you can see it ran. I'll have to close the notepad and open it back up to see the updated version. So this is what I got from the output. So you can see it put hello and then world. And you might have expected a space or a new line, but it does not put any of those by default. So if you want a space, you can put the space here after the hello. And when you run it in the file, it will end up with a space. If you want them on separate lines, you can use the \n, which I showed you earlier. So actually, let's try that out. So let me first close the notepad. And then I'll run this new code. Then if I open up back the notepad, you can see it displays the hello and the world on separate lines because the \n means go to the next line. And just for completeness sake, you can have as many files open as you want. So here I have 2 files opened. One is to write to, and one is to read from. So I read one line from file 2, then I write a few messages to file 1, and I also write the line that I got from file 2 into file 1, and then I close both of them. So if I run this program, let me close the notepad. You can see it ran, and let me open back up the notepad. And this is what you get. So printed out, well, it displayed hello, then it displayed world, then it displayed the first line of the zen.txt file. And because I didn't put a \n for the world, it did not go to the next line. It just put out the next message on the same line. So your first challenge for this video is to create your own text file and put many numbers into it. The numbers are your choice between integers or floats, and you can either put them on separate lines or put a space between each of them. It's up to you. And the challenge is to open that file and read each number from that file, then into an output file you must output what is half of each of those numbers into that output file. So if the input file contains the numbers 10, 20, 30, then in the output file you must write the numbers 5, 10, 15, and that should be done in the code. So you open the input file, read the numbers, then divide each of them by 2, and then write each of those numbers to the output file. And just one thing to remember, when you read from a file, it's in the form of a string, so you have to convert it to an integer or a float using the int or float function. And when you write into a file, it must be in the form of a string. So to write an int or a float to the file, you must convert it using the str function or using string formatting. So good luck with that first challenge. And you can pause the video now before we move on to the second topic. So the second topic we'll be covering in this video is libraries and modules. So a library is basically a whole set of code in the form of functions and classes that someone else or maybe an entire company has already written so that other people like us can use in our own programs. Now, by default, Python comes with its own library known as the Python standard library. So to use that library, you don't need to download or install anything extra. It comes with Python. All you have to do is import the modules, and we'll see how to do that in a while. But first, let's just go through the library a bit. So you can find the library at this link up here, docs.python.org/free/library. And if we go through the library, you can see all the modules in the library. So each module is a source file which contains code that you can use in your, that you can in a sense copy into your own Python programs, and you can use them in your own Python programs. But you don't actually copy the code, you just import them. And I will show you how to do that in a while. So if you want, you can go through each of these and see what they're about, or if you find anyone that might be interesting to you. So for example, there is the math module. If we open that, the math module contains many math operations. So for example, a ceil function, a greatest common denominator function, many other functions that you could do in that you could use for math operations. So you can see another one here, the random module. The random module contains many functions that you can use to generate random numbers. So that's another interesting one that you might be interested in. And there are many, many more. So if you ever want to just look through them, you can just go to this link and take a look at them. So how do you use a module? So to use a module, you import the module by typing the word import followed by the name of the module. In this case, we're importing the math module. So when we import the math module, we can basically use any function or class or variable that is in that module. So in this example, I've created a variable called x, which I've stored the number 5 in. Then I can use the square root function from the math module to find the square root of x, and it will return the answer, and I can store the answer in a variable called y, and then I can print out that variable. So to use the functions in a module, you have to do the module name dot and then the function name. And the same thing is true for classes in that module or variables in that module. So let's run this and see what it gives us. So you can see it printed out this number, which is the square root of 5. And just to say it again, the math module contains many functions that for various math operations. So if you ever need to do a program which uses a lot of math, you can check out the math module. Another very commonly used module is the random module. So if I change this to random, we can import the random module and we can start using the functions in that module. Now, one of these functions is the randint function. And what it does is it produces a random number from between A and B, and you have to specify what A and B are. So in this case, I've specified between 1 and 100. So if I print out this random number, let's see what it will give us. So you can see it gave us the number 93. So if I run it again, you can see this time it gives us the number 75. So this function from the random module creates a random number between 1 and 100, and we can store the returned number in a variable and then print it out. And just so you know, you don't have to store the variable, store the number in a variable first and then print it out. You can just print out the return from the function directly and it will work the same way. But sometimes you need the variable if you want to use it somewhere else in the program. And as you can see, this time it gave us the number 70. And the random module has many other functions that you can do to generate different types of random numbers. For example, the random.uniform it generates a random float between 1 and 100 instead of a random integer. And if you want, you can go through the random module on the web page and see all the other functions you can use to generate random functions, random numbers. There is something else I wanted to point out, which is the built-in functions in Python. So although there are many modules in the Python standard library, sometimes you don't even need to import a module from the standard library to be able to do what you're looking for. Sometimes Python already has that function without needing to import anything. And you can see a list of those functions here on this URL, docs.python.org/free/library/functions.html. So this lists out all the functions that are available in Python without even needing to import anything. So you can go through all of them and see what they all do. And if you don't find what you're looking for, you can then start looking at the Python standard library. And if you still don't find what you're looking for, there are many libraries that you can download and install on your own. A few common examples are the Pygame library and the NumPy library. So I'll show them here, the Pygame library and the NumPy library. The Pygame library is to create games using Python, and these are actual graphical visual games. And the NumPy library is used very often in math and engineering and science, and it's used to do large amounts of mathematical calculations. So if you're interested in one of those, you can look up online how to install those into your Python. So one final thing to point out before I give you the second challenge is that you can actually import as many modules as you want. So here I've imported the random module and the math module, and I can use both of them in this program now that I've imported both of them. So if I do math dot square root 2 and math dot square root 3, what this will do is print out a random number, random float between the square root of 2, which is around 1.4, and the square root of 3, which is around 1.7. So if I run it, you can see it gives me this number 1.45. So your second challenge for this video is to create many random numbers and store all of them into a single file. Then to read from that file and calculate the square root of each of those numbers and then store the square roots into their own file. And once again, just remember, when you reading from a file or writing to a file, it must be in the form of a string, so you need to do the conversions. So that is your second challenge for this video. You can pause the video now and try it on your own. So the last thing I want to show you in this video is how to use your own source files as modules that you can import into your other source files. So here in my file explorer, you can see that I have two Python files in this folder. One is called vid3.py and one is called module1.py. So what I could do is import this file into this one, and whatever functions, variables, classes, etc. that are in this file, I can use them into this one. So here on the right, you can see my module1 file, which contains two functions right now. And if I switch over to my vid3 file, you can see what I've done is imported my module1 file. So how I do that is import and then the name of the file. You don't need to put the .py. Actually, you shouldn't put the .py. Then to run func1 from my module1 file, it's module1.func, and then you run the function. So the same way you would run a function from the standard library modules, it's the same for your own modules. And here I've ran the square function from module1 using the parameter as the number 6. I've stored the return value and then I will print it out. And if you look at the function itself, the square function in the module1 file, you can see that it returns the square of the parameter. So hopefully I should get 36 from that. So let me switch over to the shell and let me run the vid3 file, and you can see it works as expected. I get the hello world from running func1, and then I get the 36 from running the square function. So that is how you can create your own modules that you can import into your other source files. So your final challenge for this video is to, based on your solution from the previous challenge, to split those up into separate functions and have each of those functions in their own module, and then import all of those modules into one source file and then run all of the functions. And hopefully, if you did everything properly, it will work as normal. So that is it for this video. Thank you for watching and goodbye for now.